it another gravity assist so that it could make it to Saturn without using too much fuel. And while it was passing Jupiter, we were able to do a little bit of research on Jupiter, along with the Galileo spacecraft that was also orbiting at the time. After Jupiter, it was on its way to Saturn, and once it reached Saturn, it made several passes of Saturn's moons, and eventually analyzed Saturn and reached its final resting place among the clouds of Saturn. So the mission, as I stated before, consisted of 2 spacecraft. The main spacecraft was the Cassini. Cassini held 12 scientific instruments, and the 2 spacecraft together contained 27 scientific instruments that all could do different things, and proved to be very lucrative in scientific data. So the Cassini spacecraft has 2 thrusters on the bottom that helped propel it through space. And for corrections and orientation, it used a device called a reaction wheel. And these operate off the principle of Newton's third law, which is an action has an equal and opposite reaction. And so what would happen is there are these discs on the side of the aircraft that would spin really rapidly in one direction. And if, as per Newton's third law, the spacecraft would rotate in the opposite direction with the same amount of momentum, and would allow the spacecraft to orient itself. And it had 3 of these reactions, which made it a 3-axis stabilized craft. The spacecraft was powered by a RTG, and that stands for radioisotope thermal electric generator. Basically, it was a nuclear battery. It uses decaying radioisotopes for heat energy. It used 3 of these, and they powered the instruments, the computers, radios, thrusters, and the reaction wheels. There was several different devices that were built to be put on the spacecraft, and to name a few, some of the, or my interest peaked on the Cassini plasma spectrometer. This measured energy and electrical charges around the spacecraft. Then it had a composite infrared spectrometer, and this sensed temperatures around the aircraft. And then it used a massive magnetometer to measure magnetic fields around the spacecraft to help analyze the magnetic fields around the planets, or around the planet and its moons. And then the Huygens probe was placed onto the side of the Cassini spacecraft, and it rode on its back all the way to Saturn and all the way to Titan. So this is what the Huygen probe looked like. It was designed to descend through the atmosphere of Titan and land safely on the ground. And it not only landed on the ground, but it transmitted data all the way through the atmosphere, and while it was on the ground for about an hour until its batteries depleted. The entire descent of the spacecraft lasted about 2.5 hours. So it was a very slow descent. It landed on Titan on January 14th, 2005, and it analyzed the atmospheric structure using the atmospheric structure instrument. And this analyzed sort of the physical and electrical properties of the atmosphere. It performed wind speed experiments using the Doppler effect with the Doppler instrument on board. And it also included a surface science package that helped determine some incredible scientific discovery over later in the presentation. So the science, the nitty-gritty aspects of the mission. We're going to begin with the main attraction, Saturn. So Saturn is one of 4 gas giants in our solar system. It's on the other side of Jupiter. Before Cassini, we've had a couple flybys of spacecraft with the Voyager missions, Voyager 1 and 2, where we've kind of caught some snapshots of the surface of the planet and its moons, and we weren't really able to collect much data with those missions because that wasn't their primary objective. Well, Cassini was designed specifically to study this Saturnian system, and so from 2004 to 2017, it was studying the entire system. Cassini was able to study the composition and temperatures of the atmosphere of Saturn, and it was able to see some close-up observations of Saturn's radion and plasma waves, which we were not able to detect from Earth, which I think is pretty impressive. And if you look on the top left of your screen, we have a picture of a hexagonal jet stream on the pole of Saturn. This image was taken in infrared by this Cassini spacecraft, and it was so all the red you see is the heat generated by the jet stream of the planet's atmosphere. The Voyager's missions discovered the hexagonal jet stream, but we didn't really know anything about it. But the Cassini mission allowed us to understand that this hexagonal jet stream has winds of upwards of 200 miles per hour. We also discovered with these close observations that there were high static discharges in the atmosphere of Saturn in the form of lightning. And we not only observed lightning on the dark side of the planet, but as well as on the light side, which both had never been done before. And so there was a lot of firsts with these observations. So as I mentioned before, the Huygen probe landed on Titan. And so Titan is a very interesting prospect in the solar system, as it could be a potential harbor of life. Now, there's a lot of speculation on that, but there is a lot of potential with the moon. So the Huygen probe landed on the surface, and while it was sitting there, it discovered, or on its descent, it discovered liquid lakes, or lakes and seas of liquid methane and ethane, and that were complemented by hydrocarbon rain. And so it has a very active liquid state on its in the atmosphere. The Cassini craft, while orbiting, was able to perform some gravitational experiments that determined, or that provided some major evidence that supports the possibility of a major underground ocean that would probably contain water and ethane, and could possibly support the theory of life on this moon. And then another prospect of research in the system, we have Eneldus. Now this moon might look a little familiar, and you might think, oh, hey, is that Europa? But no, And Europa, for those who don't know, is a moon around Jupiter, which is a very similar circumstance. It's a Enceladus is a very icy moon. It's pretty small, but the really cool thing is that the Cassini spacecraft caught this image on the top left of geysers of water exiting the cracks in the ice, and this as well supports the or provides evidence of a major body of water or ocean underneath the surface of Enceladus, underneath that icy crust. And on the bottom left, you have a diagram of the moon. And so it would have a rocky core with the ocean in the middle, and then you have that icy crust that's frozen by the harsh temperatures of space. And this too, like Europa, is theorized to be a potential for life on another world. So after all of this data, or all of the system had been explored, or for what we could explore, the fuel cells in or the RTGs began to run out of fuel around 2010, and so they had to come up with a way to end the mission. And because it has 3 RTGs on board, those radioisotope thermoelectric generators, they did not want to risk having it crash into a moon that could support life and expose them to high doses of radiation, because that would not be great. So this led to the grand finale, which was essentially a plunge into the atmosphere of Saturn. The grand finale began on April 22nd and ended September 15th of 2017. And the grand finale consisted of 22 orbits, and you can see those orbits on the bottom left of the screen. And these orbits were elliptical, and the orbits were designed to pass through the gap, that 1,500-mile gap between the rings of Saturn and the surface of Saturn. And this had never been done before. And so it was a very kind of a on the edge of your seat moment when the first time it passed through the rings. And it did this 22 times, and each orbit took about 6 days to complete. And on the final orbit, it became, the orbit was kind of an elongated elliptical, which did one more pass by Titan, which not only gave us one last look at it, but it also gave it a good gravity assist to ensure that the spacecraft would in fact have an orbital trajectory that would decay into the surface or the atmosphere of Saturn. And so on September 14th, as the spacecraft was hurtling towards the planet Saturn, it turned its high gain antenna towards Earth and transmitted its final uplink of data toward data. And then on September 15th, Cassini descended into the atmosphere of Saturn, ending 20 years of absolutely incredible exploration and discovery. And on the top there, you can see a artist representation of what it might have looked like. And after its final loss of signal, the scientists kind of had an idea, or a pretty good idea, of what would happen to the spacecraft. As it was descending, it would have burned up and broken up into millions of pieces and just disintegrated into the atmosphere. And so it was kind of a very humane way of disposing of a very radioactive spacecraft. And that is all I have for you. Does anybody have any questions?
I have a question. Do you have any personal connection to the Cassini crew or the people who worked on it?
What was the second half to the question?
Do you have a connection to any of the Cassini crew or any of the people that worked on it at NASA?
Yes. So as my mother has asked, I worked at the Bear Fight Institute up in Winthrop, and this was an institute ran and founded by Tom McCord, who has done some incredible things for science. He was one of the heads that developed one of the spectrometers. I'm not exactly sure which spectrometer it was, but it was one of the mass spectrometers that went on the Cassini spacecraft that helped analyze or collect data. And this guy also, or Tom McCord, he also helped on both the Voyager missions, as well as the Dawn spacecraft that went to, Ceres and Vesta, which are protoplanets in the asteroid belt. And he was also part of the crew that found evidence or found water in a state between liquid and solid on the moon. And so he's pretty impressive when it comes to science. And I worked there for my senior project, my senior year of high school, and where I learned so much information about spectroscopy that I didn't even know existed. And I rebuilt a Fourier transform infrared spectrometer. It used, so for those who don't know, a spectrometer uses light, or in the instance of an infrared spectrometer, uses infrared light to collect data. So basically it shoots a certain amount of photons at a sample, and a specific element will have a certain amount of absorbance or reflection of those photons. And so the interferometer will analyze the either a absorbance or a reflective spectrum and determine a like what element is in the sample. And so I rebuilt a machine that uses the Fourier transform mathematical process to convert the data from the interferometer to produce a spectrum graph on a computer. And so that was, might I say, a very exciting and brain exhausting senior project. Does anyone else have any other questions?
In the absence of other questions, I would like to thank everyone for being here. If there's anything else that you'd like to discuss with any of us or with any of the speakers, or with the speaker, excuse me, don't be afraid to speak up. I will keep the meeting open for a few more minutes. And if there are no other questions, comments, concerns, thank you for being here, and good night.
Thank you, guys. I appreciate you guys coming and listening.
Thank you for presenting.